Determine the largest six-digit positive integer that is divisible by 5. We have 6 digits to fill, and if we want the largest, I'll just fill them all with 9s. But because it's divisible by 5, the last digit has to be either a 0 or a 5. And of those two, the larger one is 5. So there you go. That's the largest six-digit positive integer that is divisible by 5. In the diagram, triangle ABC has an area of 84 and AC is 12. Point D is on AC, so that BD is perpendicular to AC. What is the length of BD? Okay, so area is 1/2 base times height for a triangle, 1/2 base times height. The base in this case is AC, and they told me that's 12. And the height is BD, so let's put that in. So this means that 84, that's going to be 6. So 84 divided by 6 is BD. And I believe that is 14. Below are 5 facts about the ages of 5 students: Adient, Bernice, Cece, Dara, and Ellis. Adient is older than Bernice, so A is greater than B. Dara is the youngest, okay. So she's less than, or he's, whatever Dara is. Bernice is older than Ellis. So Bernice is older than Ellis. So B is greater than E. And then Bernice is younger than CC. So we'll just add that there, C. And then CC is not the oldest. Okay, so let's combine all of these. CC is not the oldest, so that means A must be the oldest. And then D is the youngest. So I believe that's the order. D, and then E, then B, then C, then A. And then what are they saying? Who is the third? Okay, so the third one is B. So B, or Bernice, I guess, is the answer to the question. For non-zero integers x and y, we define x symbol y as x to the power of y plus 4x. For example, 2 symbol 3 is equal to 2 to the power of 3 times, or plus 4 times 2, which is 16. Determine all numbers x so that this is true. X symbol 2 is 12. So we just use their definition, so that would be x to the power of 2 plus 4 times x, and that is equal to 12. So put it all on one side, and I believe it would factor fairly nice. I think it'll be 6 and 2. 6 and 2, positive, negative, I think. Yeah. So that means x is 2 or negative 6. Equations: x minus 2y minus 3 is 0, and 18x minus k squared y minus 9k is 0 represent two lines. For some real number k, these two lines are distinct and parallel. Determine the value of k. So we've got x minus 2y minus 3 is equal to 0. 18 x minus k squared y minus 9k is 0. And they're distinct, okay, so that's important. Distinct. They're parallel and distinct, so it's like this kind of scenario. So they both will have the same slope, but they're two different lines. They're not identical lines. Okay, so what are we... Oh, we have to find the value of k here. So how do we do that? Okay, well, first thing I'll do is just put these equations in the form like y equals. So that will be x minus 3 over 2, right? And then on the other side, it'll be 18x minus 9k is k squared y. So then divide through by k squared. So 18 x minus 9k over k squared. Okay, so y equals this, y equals that, so excited equal to each other. I believe that's how you would do it. So x minus 3 over 2 is 18x minus 9k over k squared. But that's going to give me two variables. Let me just work with the slopes. I think that would be a little bit easier. So this is 1/2 x minus 3 over 2. The slope here is a half. The slope here would be 18x over k squared minus 9k over k squared. So this is the slope here. So that means that a half, since they have the same slope, That half is the same as 18 over k squared. So k squared is 36. Aha. So k is equal to plus or minus 6. Okay. So determine the value of k. So that makes me think that only one of those is right, because it says the value. It doesn't say values. All right, so then how do I figure out which one of those is right? I guess I'll just substitute it back into here. If I let's try k equals 6 first. If I substitute k equals 6 into there, it'll be 18k minus 36y minus 54. And then if I divide through by 18, it'll be x minus 2y minus 3. Okay, so this becomes identical, and they cannot be identical because they're distinct. So k does not equal 6, so therefore k must equal negative 6. And you can substitute negative 6 into this equation to kind of show that it is indeed a distinct line. Same slope, parallel, but distinct. Square ABCD has side lengths 2. The midpoint of BC is E. Point F is on AE, so that DF is perpendicular to AE. Determine the length of DF. Okay. So I'm thinking this might be similar triangles, or you could put it on a coordinate axis. There's a couple ways that maybe of doing this, but let's use similar triangles. So if that's theta, that's 90. This is 90 minus theta, this angle in here. And very similarly, that angle would be 90 minus theta, and this would be theta. And of course, that angle that's at F is it's a right angle. So that definitely proves that triangle ADF is similar to triangle ABE. So therefore, we have the ratio of the sides would be the same. AF over BE would be the same as AD over AE. And let's see what I can put in terms of filling this in. BE is 1, right? Because the side length is 2 and E is the midpoint. So BE would be 1. AD, well, that's 2. AE, oh, that I can figure out with Pythagoras. So if we have A, B, and E, this is 1, that's 2. So AE would be 2 squared plus 1 squared. So AE would be root 5. So there you go, root 5. So AE is 2 over root 5, basically. And then what do we have to do? Figure out the length of DF. So where's DF here? Okay. Now, how do I do that? Probably just Pythagorean theorem, I would think. Yeah. Yeah, because I have AF and I have AD. Okay, that would be fairly straightforward then. So DF squared plus AF squared is AD squared. And then DF is what we're trying to figure out. AF I just did was 2 over root 5. And then AD is just 2. Okay, so that's going to be 4 minus 4 over 5. And that is what, 16 over 5? And then that's DF squared. So DF would be the root of that, which is 4 over root 5. And if you rationalize the denominator, it would be 4 root 5 over 5. Determine the number of ordered pairs of positive integers AB for which 20A plus 21B is 2021. Okay, so I guess we're just looking for integer solutions to that equation. Now, these kinds of questions, what usually happens is you start with the lowest, they're positive integers, right? So you start with the lowest one, which is 1. So you plug it in, and then you kind of say, okay, let's see, what do I get for B? And if it's an integer, great. If it's not an integer, you keep going. So whatever, it's 25.2. And then you see what it happens for 2, and then you see what happens for 3. Usually what happens is you get a pattern. So for example, this will be an integer, and then this won't, but this will be an integer. You see what I'm saying? So you can say, oh, okay, every third one. But unfortunately for this question, you don't get an integer for a long time. And then you don't get an integer for an even longer time when you keep going. So it takes forever. So we have to kind of narrow this down. And what we'll do is we'll look at this to narrow it down. We have 20a plus 21b, and they're saying that's equal to 2021. Okay. Well, anything that's 20a, any number that's 20a, whatever it is, its last digit or units digit is the proper term, is going to be a 0. Okay, so you can try it, whether you put a equals 1, whether you put a equals 5, whether you put a equals 20, the units digit will be 0. So something that has a units digit of 0 plus this has to equal that, but this has a units digit of 1, as you can clearly see. So that means this has to have a units digit of 1. So whatever it is, its units digit has to be 1. Okay, so that means that b has to have a units digit of 1, whatever b is. Otherwise, the units digit of 21b would not be 1. It would be something else. It would be 2 or 3 or whatever. So that helps us because what it does is essentially narrows it down for us. Instead of having to go through every single A, B, C, like 1, 2, 3, 4, 5, all the way up till who knows, we can just narrow it down to B's that have a units digit of 1. So 1, 11, 21, 31, and so on. And that, it's still several numbers, but as you can see, is not that many. And then eventually, you will run out of, eventually what will happen is you can stop because you'll start getting negative values for A, and both A and B have to be positive. Okay, so this isn't so bad. So then what you do is you plug in values of B into this equation, and you will get the following. You will get 100. You will not get an integer there. You'll get 79, because we're only interested in integers. 58. You will not get an integer here. 61 will give you 37. 71 will not give an integer, and this will be 16. That's not an integer. So the only values of A, B that are both positive integers are 101, 79 and 21, 58 and 41, 37 and 61, and finally the 16 and 81. Amanda has 2 identical cubes. Each cube has 1 integer on each face, so that the following statements are all true. 3 adjacent faces of each cube have the numbers 15, 9, and 4. The numbers on all pairs of opposite faces have the same sum s. When both cubes are rolled and the numbers on the top faces are added, the probability that the sum equals 24 is 1 over 12. Determine the sum of all possible values of s. Well, we have 4, 9, and 15, and the other ones I have no idea, so I'll call them A, B, and C, the other faces. But if you were to kind of open this up, it's going to be a little bit easier to explain if I opened it up. So this is my cube, right, that I've opened up. Well, the 15 goes here, the 9 goes here, and the 4 goes here. So I'll put the A here, the B here, and the C there. Now they're saying that opposite faces add up to S. So A plus 4 would be S. And then 15 plus C would be S. And what's the other one? 9 plus B, I believe. Yeah, would be S. So that tells me that A is equal to 4 minus S. C is equal to S minus 15. And B is equal to S minus 9. Okay, so now we have to go through the painful procedure of figuring out sums. Sums, like when you roll them, there's 2 dice, remember. Yeah, there's 2. They 2 identical cubes. So when you roll each one, you're going to get one number that is sitting on the top. So, for example, if you rolled the first one and the second one, and both of them showed 4, the sum would be 8. And there's 6 possibilities for the first top face, because there's 6 numbers, and there's 6 possibilities for the second. So 6 times 6, you have 36 possible outcomes. in terms of the sum. So I'll just do the first one, like, to sort of show you. Let's say the first one was 4, first top face. The second could be 4, 9, 15, any of these guys. And I'll write out what it is in terms of S. Oh, did I do this right? Sorry. I think this is S minus 4. Sorry about that. Oh boy. Okay, so then S minus 15, and then S minus 9. So the sums would be 8, 13, 19, S minus 11, and S minus 5, I believe. Got it? And similarly, you do the same thing for what happens if 9 shows up on the top face of the first die, and then the other die could have one of these possibilities. Same kind of story. And then you just add up the sums. So these sums are 13, 18, 24, S plus 5, S minus 6, and S. Got it? So similarly, you're going to do all of these. So I'll just do the sums, because I'm pretty sure you could do all of these. So I'll do the sums for when the first is 15. That'll be 19, 24, 30, S minus 11, S plus 6, and so on. So let me complete the table, and I'll come back. So I went ahead and filled them all out, just so you have a complete understanding of what's happening. So these are the 36 sums, right? Okay, so let's go back and see what is it that they're asking. They're basically saying that you've got the probability that the sum is 24 is 1 over 12. Okay, so the probability is 1 over 12 that the sum equals 24. So these are all the sums, right, that I've figured out, all of these guys. Now let's see, are there any 24s first of all? Let's see, there's one 24 here. Is there another 24 anywhere? Interesting. There has to be, right? Oh, there's one. Oh, okay, here it is. All right. So there's 2. Now, there's 36 different sums, so let me just make that over 36. So that would be 3 over 36. So that would basically mean that of all the 36 sums, 3 have to be equal to 24. But so far I found only 2, this guy and this guy. So at least one more has to be equal to 24. And if that is the case, then that will hold true. Now, some of these are already numbers, right? So obviously I can't make those into 24s, but I could turn some of those that are in terms of S into 24. But only one. Only one. Now, here's the problem. There's an S. I say, okay, well, let me just make that 24. But the problem is there's 2 of them. If I made S 24, there'd be more than 1, and that would mess up this probability. I only want one more sum to be equal to 24. Okay, so S is out. Anything that has more than 1 will be out. And obviously the numbers are out because those are already established numbers. So S minus 11, let's see, is there any more than, yeah, there is, so that one's out. S minus 5, I'm pretty sure I did a S minus 5 somewhere else. Yeah, there's an S minus 5, that's out. S plus 5, okay, let's see, is that a good candidate? No, because that appears again. S minus 6, okay. I think that might be a good candidate. And let's see, are there any, oh, there is, okay, so that's no good. S, well, we already talked about S. S plus 6, is there any S plus 6? Yes, there is. S plus 11, is there any S plus 11? Is there any S plus 11? Oh. Sorry, I think this was an S plus 11. Sorry about that. So that means S minus 11, 4 and S minus 15. There it is. Okay. So yeah, I gotta make sure I fill out the table correctly. Okay, well S plus 11 is gone. 2S minus 8. That one I believe only appears once, so that's one of our candidates. Yeah, that's interesting, and I think it's when both of them are the same. Yeah. Okay, so then 2S minus 19, that appears twice. S we already talked about. 2s minus 13. That appears here. 2s minus 30. Okay, that one I think is a candidate because, see, that's when both top faces are the same. And then 2s minus 14. S minus... I think this should have been a 24 here. So that matches with that. And then this is the only one left. 2s minus 18. Okay. All right, so finally, it's just time consuming. The actual mathematics is fairly straightforward, but it's just time consuming. So these are the only candidates that will appear once. So when we set these equal to 24, we get the following values for S. 16, 27, and 21. So they want the sum of these guys, the sum of all possible values of S. So 16 plus 21 plus 27, that is equal to 64. So that would be the final answer to this question. Celine traces paths on the grid below, starting at point X and ending at point Y. Each path must follow the lines connecting the dots and only ever move horizontally to the right or vertically down. It may be useful to know that there are a total of 924 such paths. Consider the 7 points labeled A, B, C, D, E, F, and G. List these points in decreasing order of the number of paths passing through that point. For example, B is on exactly one path, so B should be the last point in your list. I will explain in detail how you will calculate each one. And I'll do, let's see here, maybe A, B, C, D, and then E, F, G I'll let you figure out, because hopefully by the time I do those first 4, you will become an expert and you'll be able to figure it out yourself. Okay, so I think the diagram is all I need, so here we go. For A, the first one, we have to go from X to A. That's sort of my first one. I have to go right once. So I'll put R for right. And that's it. So I have only one choice, and from those one choices, I choose that one choice, and that's 1. So pretty straightforward there. But then I have to also calculate when I go from A to Y. To go from A to Y, I've got to go 1, 2, 3, 4, 5 times right. And then I've got to go 1, 2, 3, 4, 5, 6 times down. Like that. So, but I can do it in any order. So, of these 11, I'm going to choose 5 for the R's. And then from the remaining 6, I choose 6 for the D's. And when you calculate 11 choose 5 times 6 choose 6, you will get 462. The total path from X to Y, from X to A to Y, that you take this number and you multiply by that number. So 1 times 462. So that would be 462, obviously. So I'll make a little list here. A is 462 in terms of how many paths go through that point. Okay, so we took care of A. Now let's talk about B. So B, same kind of story. We're going from, first we need to figure out going from X to B. And that's going 1, 2, 3, 4, 5, 6 going R. And that's pretty much it. So from those 6, you choose 6, and that's just 1. Then we have to go from B to Y. Well, that's going down 6. So that's pretty straightforward. From those 6, you choose 6, so that's just 1. So 1 times 1 is 1. So B is pretty straightforward. So the first two, not really that interesting. But then we start getting interesting with C. C requires a little bit more work. First, we have to calculate from X to C. And that'll be 1, 2, 3 going, we have to go right 3 and down 2. Yeah. Is that right? Yeah. So then to figure it out, it'd be from those 5 choices, we choose 3 to be the R's. And then from the remaining 2, you choose those 2 to be the D's. And then 5 choose 3 times 2 choose 2 is, I believe, 10. So there's 10 different ways of arranging 3 R's and 2 D's. Now, in case you're a little confused, I'll just write down a couple. You can have R, 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 D, D, or you can have R, R, then down, and then R, D, and so on. And there's 10 such combinations. So then we are not done with this C guy. We have to then figure out from C to Y. From C to Y, it would be 1, 2, 3 D's. D, D, D. Sorry. 3 R's, I should say. Yeah, 3 R's, R, R, R. And then 1, 2, 3, 4 D's. 4 D's. Yeah. Okay, so that calculation would be 7 choose 3 times 4 choose 4. And then that is, I believe, 35. So then you have to take this and multiply by that. And when you do, you get 350. So C has 350. Well, did I do that correctly? C. I think so. Yeah, I think so. Okay, so let me just do one more because I think by now you get the hang of it. I'll do D. So D is the next one. D, to get from X to D, we had to go 1, 2, 3, 4, 5, 5 right. And then we had to go down 2. So that means from those 7 you choose 5 for the R's, and then from the remaining 2 you choose 2, and that'd be 7 choose 5, that's 21. And then finally you go from D down to Y, so that's going to be 1 R, and then 1, 2, 3, 4 down. So that means from 5 you choose 1 for the R, and the remaining from the 4 you choose 4, and that's just 5. So total that'd be 21 times 5, and I believe that is 105. Okay, so hopefully you have become an expert. And for E, for F, and for G, I'll give you the numbers. I'll let you calculate them, because I'm certain that you can by now. So E is 224, and F is 400, and G is 225. So if we list this from biggest to smallest, so the biggest is 462, and that's A. The next one is 400, and that's F. And then the next one is 350, and that's C. And then 225, which was G. 224, which was E. And then 105, which is D. And then finally 1, which was B. So A, F, C, G, E, D, B. Oh, hold on. AFC, A, F, C, G, E, D, B. Yeah, that's the order from biggest to smallest. A, B, C, D, E is a pyramid with square base A, B, C, D. Point E is directly above A, and AE is 1024, and AB is 640. The pyramid is cut into 2 pieces by a horizontal plane parallel to ABCD. This horizontal plane is a distance h above the base ABCD. The portion of ABCDE that is above the plane is a new pyramid for how many integers h is the volume of a new pyramid an integer. So the first thing I need to draw is a plane, a horizontal plane. So let me draw that in. So that's a pretty decent illustration, I think. And let me label it. So we went A, B, C, D, E. So we'll go F, G, H, and I. And then this distance is small h. Yeah, the plane is h above the square base. Okay. All right, so let's see. 640 is AB, and then the whole top to bottom, A to E, is 1024. So that whole top to bottom from E all the way down to the base A. So what are they interested in? They're interested in the volume. Okay, so the volume of a pyramid is 1/3 the area of the base times the height. So height. Okay, so in this case, what are we interested in? The volume of the new pyramid. Okay, so the one that's above the green base that I drew. So that's going to be, okay, so I have to figure out the area of the base here. And how do I do that? I don't even know what that base is. Well, at least I know the height. The height would be from here to here. That would be 1024 minus h. So at least I know that. Okay. The base, okay, I have to get that base, I have to discuss this a little bit here. Trying to see how do I get that base. I think we have to look at a similar triangles. So for example, if you have triangle EFG, that's going to be similar to the big triangle, the whole E, which is EAB. I think that's a very straightforward way of figuring out these dimensions. So that means that EF over EA would equal FG over AB. And I think most of these we know. EF is 1024 minus H. EA, well, that's 1024. FG, that I don't know, because that's going to vary. And then AB, well, that I know, 640. So that means FG will be this whole big long song and dance, which I believe in lowest terms is 5 over 8, which the 640 over the 1024, and then you just multiply by that 1024 minus H. Okay. But I think I think I figured this out, because this is a very important point right here, that ABCD is a square base. It doesn't look like that, but that's just because of the way it's drawn, but it's a square. So that means if you draw a plane that's parallel to ABCD, which is what I did in green, that's also going to be a square. So that's also going to be a square. So that means that that plane FGHI is a square. And therefore, if I know FG, then I can figure out the area of the base. The base area will be the area of the square, which would be just FG all squared. And that's it. And I think that's pretty much all there is to this question. And then I have to substitute in FG and then figure out for which values of H the volume will be an integer. Okay, so let's do that. So we got volume is equal to 1/2 FG. Well, FG is here. So it'll be 5 over 8, 1024 minus H. All of this squared, and then 1024 minus H. Okay, so if I do this, let's see, this will be 5 squared, 8 squared. Okay. I'm going to try to put in prime factors. I think that will help me. So 8 is 2 to the power 3, so that would be 2 to the power 6. And then this 1024 minus H, that just appears 3 times, so that'll be to the power 3. So we want this guy to be an integer. Let me just first see if I did. Sorry. Oh, geez. This should be a 3. I don't know why I put a half. I put 3 up here, and then for some reason I started putting halves. Okay, good thing I caught it. Okay, so this is correct. So for some reason, or somehow I should say, we want this to be an integer. So we want this thing to be an integer, and we have to figure out what values of H make that an integer. Oh boy. So how do I do that? Well, the 5 to the power of 2, that's sort of already an integer, so I think we only need to concentrate on this 1024 minus H all to the power of 3 divided by this 3 times 2 to the power of 6. Now, what is 3 times 2 to the power of 6 in terms of a number? I think that's 192, right? So we basically want 1024 minus h to the power 3 divided by 192 for that to be an integer. And then whatever it is, if you multiply it by 5 to the power of 2, it's going to be an integer. Okay, so 1024 minus h to the power of 3 has to be divisible by 192. That's essentially the interpretation of this. And I have absolutely no idea. So, especially consider it's a power of 3. So what I'm going to do is in a painstaking way, kind of experiment with numbers here. So we'll have this here, and then does it equal an integer for different values of h? And let's see what we get. And this will be time consuming. Well, it's number 10, so obviously it's going to be challenging. And the hope is that you get a pattern. So did they say anything about h in terms of what it can be? Like, for example, is it an integer? The distance h. How many? It is. Yeah. Integer. Yeah. Okay. It does say that it's an integer. Okay. So the smallest integer that's positive is 1. So let's do that. And then I'll let you calculate this. And the answer is no. When you put 1 equals h into this expression, it does not equal an integer. Okay, and you keep going like this. And the first time you'll get an integer is when h is 4. And unfortunately, you have to keep going like this. And then the next time you get an integer is when h equals 16. And the next time you get an integer is when h equals 28. And so on. But you'll notice there's a pattern here. 4, okay, well, 4 is the initial one. But 16 is 4 plus 12. And then 28 is 4. 28 is 4 plus 2 times 12. And that's basically the pattern. The next one will be 4 plus 3 times 12, which is 40, I believe, and so on. And then you'll keep going until you get to the very largest that h can be without making this a negative, which is 1012. And that is basically 4 plus 84 times 12. And then you just have to count all of these guys. So you went from 1 times 12, 2 times 12, 3 times 12 to 84 times 12. So those are 84 of those. And then don't forget that guy. So it's a total of 85. So it would be a total of 85 values of h for which this volume, the volume, is an integer.